Hello, in today's video I will show you how to create the complete piping system from scratch using components that we created in our previous sessions. For that, we will copy some of them from one project to another, and in this case we will use bolts, weld neck flange, flow arrow, isonote, wall penetration, pipe shoe, butterfly valve, ball valve, socket weld, ball valve flanged, instrument connection, elbow, blind flange, and reducer. These are the most common components that you will work with on every single project related to piping or mechanical design. And now we're going to start. So what I did, I just copy pasted it from one project to another. You can also use, in your case, such a tool as transfer project standards that will copy all the families associated with pipe fittings and pipe types to your new project. So next step will be to define the routing preferences with creating the new pipe type instance. So I will just copy one of the existing ones. Actually, I will remove most of them. I will leave only one that we call dummy, and I will copy it and rename it. Now we're going to adjust the routing preferences. As you can see here, and the pipe type we already have defined it. Actually, I copied it from the other project where it was already defined. So here we have as predefined property Pipex spec, description, standard, material, manufacturer, units of measurements, nodes, and types, etc. And types is one of the critical points because those properties will be essential to create the isometric drawings in a proper way. So now let's open the routing preferences and let's define here our families that we are going to use. To make it easier, I will remove all the families that we already pre-selected as they were copied from the previous project. Now we go to segment and sizes and we're going to modify or create the new segment. In this case, I'm going to clean up the ones that we have already, because most of them are not that necessary, especially for our current case. So I'm going to leave only 10S stainless steel and we will use it as a base. The rest I will just remove. So once it was removed and we have only one 10S, we're going to they were used in both of them, so we cannot really remove them that easily, so that's fine. Right now we will review the properties of the lines. So actually, as you can see here we already have pretty decent outside diameter and internal diameter. Combination of those properties will give us the wall thickness of the pipe, and here we also have defined nominal diameter. So per nominal diameter all the components will be sized. The only thing I'm going to clean is the diameters up to DN15, because lower than DN15 we don't need. Let's click on OK, and we are starting to add in the routing preferences. Here first we are going to define elbow that we are going to use. In our case it will be elbow that we have created in one of our tutorials. Then as a T I will use the branch connection that we specially created for Revit. Then we will define the transition that will be our regular dummy, and basically that will be it, because unions, flanges and caps, they are not that decent in that sense that we are not really going to use them. So I'm going to click OK, apply, And basically that's it. Now what we can do, or what we are going to do, we're going to start to route a pipe. For that we have two ways. First way, to go to piping systems, click on pipe and route the pipeline, or we have also second way, we can click on the piping instance that we have here and we can just drag it to the place where we would like to have it, and we can also create a pipe. Right now, as you can see, the pipe does not display as it should be. So what we are going to do in this case, we are going simply to adjust the graphical appearance of the components that we have in this case. So we are going just to adjust it to fine. So from here, what we are going to do, I'm going to add a few elbows, and for that what we will use in this case, we can just select the ending point of the pipe with the right button and click draw a pipe, and from here we can already start to draw our pipes. Holding shift, you can prevent pipes from having funny angles, and if by any reason you would like to have those angles, software can assist you with that, to have more or less precise rounded value for the angle. So we will keep it 45 and we will just continue drawing the pipe. What are we going to add next in this case? Next, let's imagine we have something connected from both sides. So I'm going to add flange connection. In our case, it is stored in... Okay, here is the component that we are going to add at the end. We will going to add one flange from one side, weld neck flange, and the other one will be from the different side. Let's say we are going to simulate that there is an equipment is connected, and of course for every equipment we need to for sure add gaskets and the bolts. For that, right now we need to find the gasket family and the bolt family. Let's see if I have copied it, because regarding the gasket I'm not sure. So for that, let's jump back, find the gasket that we would like to use. Here, as you can see, we have defined two types of gaskets. First gasket is just for regular connection, and the second one is for connection when you don't want to model bolts in your you don't want to see bolts modeled in your project, but you still would like to see them on the isometric drawing. So I'm going to place it here. We will use both cases just to showcase how it works, and we will just copy it to the final project that we have over here. Then I'm going to place them somewhere so they appear in the family browser, and we are going to edit from one side and from another. And of course we need not to forget about bolt sets. So here come bolt sets that we modeled from one side and the bolt set from different side. And as you see, it works perfect. So the next step will be, once we finished from one side and another, I'm going to add two butterfly valves. Let me only check one thing. Yeah, it's DN150, so it should be decent in this case. So I'm going to add butterfly valve from one side to isolate the equipment, and I'm going to add also butterfly valve from different side to isolate the equipment. And now what we're going to add, the same as we just added over here, we have two flange set connections. To make our life a bit easier, what I'm going to do, I will just copy them and place them in a correct position. For this one we will just go to the, I would say in case of the family that we have right now of the butterfly valve, the best way will be to use a side view. So I'm going to use side view and copy paste the butterfly valve over there, and the other one will be from this side. And for different side we also will do the same. We will copy it just to prevent redundancy. And from here, and then we also go to here. So now we have those components corrected. The only thing we need to do is to reconnect our components to the desired locations. And then we need to check if those components are actually connected, and as you can see over here, they are connected only partially. For that, as I mentioned in one of the videos before, we need to go to Analyze tab and enable checking the pipes if they were connected or not. And then we can see clearly that here, two pipes, they were not connected. To solve this issue, I'm going to use the tool that we created to solve cases like that. For that I need to select components that I would like to reconnect. In this case it will be gasket from one side. Okay, it doesn't work. Maybe like that. Yeah. Now as you can see, it was resolved from one side, and from this other side we will repeat the same exercise. So now we also go to our plugin tab, reconnecting the components, and here it is. Everything was reconnected. In this case, let's say we also have here butterfly valve, so right now we have two bolt sets, but I would like to have only one of them visible. Also, we haven't covered it in our families, but here it's clearly visible that it is lag type butterfly valve, but we will imagine that it's just usual butterfly valve wafer type. So what I'm going to do, I'm going to enable or disable one of the bolt sets, and for this one I just need to click on one of them, and let me see. No, it's custom, but I don't need the custom. I need. Okay, I don't have it here at all. What a shame. We will make it easier. We will just delete it. We will just delete the family because for sure we don't need it, and make this bolt set a bit longer, like 60 millimeters longer. And so the regular bolt set length will be 150. So let's imagine it will be oh no, yeah, I think it will be around 150 or even 140, depending on the pressure ratio that we are using over there. But in this case I think it's PN16. Flanges are currently PN10, but we can also change it to PN16, and the bolt set also can be updated to PN16. But PN16 doesn't work because it was not covered by the family that we have created before, so we will stick to PN10 as a showcase. But in your case, of course, make sure that everything matches each other. We are done from one side. From different side we're going to do the same. So we're also just deleting the bolt sets, then reconnecting the components and making our bolts a bit longer. I cannot see the property. Yeah, it's over here. So it's also will be 140. And here it is. Next step will be to add a few supports. So we are going to find our supports that we have created in advance. It should be here. This is the pipe shoe, And I'm going to select just a few random locations. Let's say I would like to have one pipe shoe here. Let's say a second one close to an elbow. The third one will be somewhere over here. The fourth in the same location, and the last one very close to the last valve. But let's shift it slightly from one side and also from different one. Let's relocate it at all. So from this side, I'm just going to move it to the right. And I'm going to add same pipe shoe. Cool. Now all the supports are in place, or at least in my opinion all of them are in place. And a few components here that we are still going to add. The first component will be the support component. I mean, like annotation kind of component. So it will be flow direction. To adjust the flow direction, we need to navigate to the plumbing view, because in 3D model you will not see the sign. Then we will go into flip it over, because here we already told, or maybe not. Let's imagine that from this side we have a pump, and from this side we have a tank. So it always goes from tank to the pump, yeah. And we will be the Captain Obvious today. Then we're going to reconnect it. Yeah, with this component it doesn't work that well. We still need to fix it. But if I manage to click on the right spot, then it might work. Nope. Okay, then probably we need to just do it manually. Like that, yeah. Now it was reconnected. Of course, let's imagine that we have a wall somewhere over here. So we're going to use wall penetration to make it more interactive. We are going to draw a very simple wall over here to show you that the family is actually capable in creating the physical penetrations and dynamically adapt based on the diameter of the pipe. So here we will see actually what we need to do. We need to go to modify, select the wall. It's not visible because we have not the best view available over there, so let's keep it architectural for just for a second. And what I'm going to do, I'm going to click like that, and now the wall penetration was created in the wall. As you can see, it's slightly bigger, so it already considers that we are going to add isolation a little bit later. So for now we'll continue. Where it was, yeah, let's keep to none. And here we have the flow direction, here we have wall penetration. Let's see what's left from the components that I promised we're going to add. ISO node, of course we're going to add an ISO node. So let's imagine actually it's a wrong type of ISO node, so I need a different one. So let me just do that in a different way. So ISO node that I need here, let it be just simple message. Then I'm going to copy it. and we are going to use it over here. So for example, in this case I would like to tell that from one side I have connection towards the pump, and from different sides I will have connection towards the equipment. Perfect. What I'm going to do next, we will add a few drains and instrument connections. So for sure we don't need to have drain over here, but before the pump for sure we need to have a drain. And of course, what will be the mandatory in this case, we need to also have a reducer over there. And for sure it will be not that easy, but we can make it. So I'm going to select the whole set, and then I'm going to change it to 100. Let's imagine the suction line will be 100. Yes. So here right now we have our reducer, but to make sure it's accurate we need to displace the reducer together with the connection that we have here, and then we need to make sure that our reducer will have the eccentric configuration. So let me see, how can I do that? It was definitely somewhere here, yeah, type 2, and then I'm going to just twist it around. Yes, that will be the correct configuration. And what I'm going to do, I'm just going to connect it to the right spot, so the disconnection is not there anymore. And that will be about the reducer. Then, unfortunately, to add a drain, we have not that many options. The simplest one will be, of course, to add the drain from the side view, but let's cover two cases right now. So we're going to create two drains. Actually, we're going to create one drain and one instrument connection. So the drain we will create from this view, and for that what I will do, I will click on pipe, then create similar, and on create similar I will select, for example, let's say DN25 I would like to have, and the elevation of it will be slightly lower than the center line of the pipe that we see right now. So let it be 400 millimeters lower, for example, 350. Straight pipe on plus minus this elevation, as you can see right now on the screen. Yeah, okay, I need to displace it for a bit, because by default in my case it started from the branch connection, and then it starts to adapt according to the lookup table. And as you can see here right now we have two options. We can create a drain connection over here or over here, depending on your preferences. And actually the only way from the side view will be to create it on this location, and from 3D view you have two options. You can create or over here on the vertical, on the horizontal part of the pipe, or on the vertical pipe. So right now we're going to add those drains. For this we will use globe valves that we copied from the previous project. So we are going to place it over here. As you can see, it was placed. Let's add some extra space over here, so we have enough room to place flanges together with other components. And what I'm going to do, I'm going to shorten it for a bit, just to make sure that I have sufficient room to add gaskets. So now I'm going to add gaskets. It's here. And this particular case we will use when we don't want to model bolts. So I will only put gaskets from both sides. Oh, wrong one. Yeah, it's quite tricky to snap from. It always tries to snap to the different component. It's quite irritating. Yeah, now it was like that. Then I'm going to add one attribute over here. Well, actually, I'm lying. I don't need to modify any kind of attributes, so it's already quite okay. Now I'm going to add flange, blind flange. Oh, pardon. Yeah, let's have a blind flange from one side. We will place it like that, and from different side we're going to add. Let me see. Also weld neck flange, of course. So I'm going to add here weld neck flange. We're going to create it like that. Then I'm going to the front view and adjusting the connection to make sure it's matching. And now, as you can see over here, we created a drain connection. And now I will show you also how you can create the pressure gauge connection. For that, we go to the plumbing, we go to the top view, and then we're creating the section right in front. Then we're going to this view. Let's make it fine, just to make sure that we can see all the components over there. And the only problem that I already explained before, once I will try to edit, it's always suggests to start from. Yeah, that's what I meant. So let's try to have a workaround over here. No, still doesn't work because we don't have enough room to place. Yeah, that's one thing that we need to modify in our family, just to make sure that by default, when it's still nothing over there, it uses a simple kind of connection, and then it adjusts based on the requirements that we have. Yeah, we need to see it. Yeah, we need to see how to do that, but nevertheless, we can just make a bit more room over here. I will just displace it for a bit. Let's have it like that. And now I'm going to add additional component. It will be 25 pipe. Let's say we need some room over there. And for this place we are going to use socket via 12. I think that will be it. For sure we're going to add also the flange. Then gasket. It will be same setup without bolts, just to make our life a bit simpler. Then we're going to add a blind flange, and the instrument will be connected to the blind flange. And for this one I have already pressure gauge created, and we're just going to place it on the top like that. Yeah, for simplicity. And now, as you can see, we have created the whole set of components that we are going to use to create our isometric drawing. So right now, as you can see, we created the flanges, bolts, gaskets, supports, different kind of valves. I'm going to remove it just to make sure that we are not distracted by that. Then of course we have also valves. Oh, pardon. We have all annotation components. And let's see what we've been thinking to use. I think we used all of them. So basically it's the basic components that you are considering to use and create over your journey. And here, now we're going to prepare it for isometric extraction. So here I'm going to add very simple tags to the valves. Let me see if I haven't defined those properties. Of course I did. It's just quite complicated to find them. Yes, here it is. And let's call it Px001. Then it will be Px002. Then Px003. Give me a second where it was. Over here. Then we are going to the different side. And here I'm going to name it Px004. So that would be it. Item tag 004. All the essential properties, they are already in, as they were created in advance, and all the values are already assigned. A bit more details you can find in the user manual that will be provided together with your the plugin upon to your request. The only thing that we right now need to make sure that it's set, we need to ensure that we have selected pipe spec, because it will help us to create the structure of our PCF document. And I'm going to call it also dummy. Who cares at this point? Because all the components that we used so far, they were dummy. And let's make it more interesting, and we are going to for sure indicate the conditions. So let's say test pressure will be 16 bar. Test pressure always the environmental temperature. Test type, let's say hydraulic. Density, it will be simple water. Category PD category art 4.3. Yeah, let's imagine, doesn't matter. PD group 1. PD table, service code, let's say warm water. Service description, warm water. Phase liquid, design pressure, let's say 10 bar, temperature 100, heating not applicable, insulation spec, insulation spec will come from the insulation type that we are going to use just as a insulation thickness. So here we are going to indicate nothing, and then we are going to indicate as a test pressure, operational pressure, let's say 2 bars, and the temperature will be 16 bars. Line number will be equal to the name of the system that we used here, and actually that's the point that I forgot to mention. I'm very sorry about that. But when you start creating your piping system, make sure that when you start to create your pipe, you have selected correct system type. Here I already had it predefined. And what kind of problem you might have, that it might be possible that right now I cannot change it to the other system, because that's, yeah, let's say that's the Revit's limitation. It has some intelligence behind, and to make sure that you can replace one system with another, it must relate to the same default category. But right now, as you can see, this is not the case. So what I'm going to do, I'm going to use a workaround. I'm going to delete the pipe system that we have over here, and I'm simply going to add the one with the correct system type. So then everything will be inherited. Where is it? What the heck is going on? Nah, just wait. I don't know. Just a bug. No worries. So, okay, now we see it over here. Here it has the proper system type. So I can just reuse, or I can just remove this part and adjust it. And now the whole system has the proper classification. But for current exercise, it's not that important, so I'm going just to move it back, because I already added a dozen of properties. So the rest of the properties you can also insert, and they can be also extracted with our plugin. But let's focus on primary ones. So that's it. And what I'm going to do now, we go to the tab, click on settings, we select Pipex tab and go into settings. And the settings, we need to verify if all the attributes has been selected and they are matching to the one that we need. So here in my case, I need to still adjust the attributes for ski and the type, and also for the spec. I just need to find it in the list. Yes, it's here. Then I'm going to check the rest of them. If all of them are available. Instrument is here. Support secondary steel reference we're not going to use now, but what we can do, we can use a tag. It's totally fine. So I'm going just to select all of them as visible in view, and I will assign them the same tag, because let's say they will use the same type of the secondary steel support. So it will be ST001. And that's it. I will call it, doesn't matter how, abracadabra. And then I'm going to the systems to export the PCF file for the whole system. Then I'm selecting the system from the list, clicking export, and selecting the location where I would like to save it. I would like to save it to my desktop, doesn't matter, at least for now. And to create the isometric drawing, of course, in Revit directly it's not possible, but what we are going to use in this, we are going to utilize another Autodesk's product, AutoCAD Plant 3D. Let me just start it up quickly. And now we will create the isometric drawing. For that, we need to go to ISOs tab, select PCF to ISO button, and then I just need to find the PCF file that I just created. Then we can check the advanced settings. What do we have here? What kind of options? So for example, the most important will be create extra splitting points depending on how the isometric drawing is loaded, how many items does it have, etc. So you can define also how many items you would like to see per isometric drawing, so I will leave it as it was. Then we click OK and click create the isometric drawing. And now we will just wait. Yes, it was created. Here we see that it decides to split it in 2 sheets at least. And now let's review the content of it. And here, as you can see, we have all the items that we have created in the model, together with all the information that we have added, as well as the annotation components, supports, drains, connection types over here, with all the dimensions of course. The content of the sheet can be adjusted based on your Plant 3D project settings. Let's see this. What do we have on the second sheet? Here we have our wall penetration, together with all the supports, bands, valves, and annotation of course. Here in the bill of material we have all the details that we need to know for purchasing. And here we have all the details related to the process conditions of the system. So that will be it for today. If you would like to know more about our tool, feel free to contact us via the contact data that's available on our YouTube channel or in the comments below. Thank you for watching and see you next time.